In this video I will be discussing section formula and we'll be solving 13 questions around this along with the concept. So let's recap what we have learned so far on high level. So far we know what are the coordinates, polar Cartesian coordinates. Also we learned how to calculate distance between 2 points and transformation of axes and origin. Also, I will be covering the derivation of each and every formula. Derivation may not come in your exam, but it is always important to know why this formula works, right? At least you should be trying derivation at least one time before memorizing it, right? So ultimately by practice you will get used to this formula. This is very basic and during complete course of coordinate geometry you will be using this formula. As the name suggests, this is something related to section. If we have 2 points x1 y1 x2 y2 and if we try to make or divide this line into multiple segment, one point will be dividing into two sections, right? So that's why this comes section, and formula is the method by which you get this point. So let me write the formula first, then we'll come to derivation. So this point x and y, this will obviously divide this line segment into two portions, and if you know the ratio of these 2 points, m:n, this is the formula, m plus n. The easy way to remember this is to multiply m to this coordinate and n to this coordinate. mx2 plus nx1 over m plus n, and similarly for y coordinate also, my2 plus ny1 over m plus 1. Alright, and this is called internal division. What is internal? Means the point is on this line but it is dividing internally into two sections. If the point is above this segment, then that will be called external division. So the meaning of external is x1 y1 x2 y2. If some point here, let's say P, alright, A, B, this will obviously divide in a different way, right? The measurement of P from A and P from B, the ratio of that is m:n. AP over BP is m over n. So this is external division, and to get this point, the formula is exactly same with negative sign, mx2 minus nx1 over m minus n, and y is my2 minus ny1 over m minus n. So never ever try to memorize any formula without at least one time derivation. You should be understanding how this works, right? Because some of the question may be related to the way it is derived, like angle bisector theorem. That is useful to derive some of the formula later on in this section. The proof is very simple. x1 y1 x2 y2, these are 2 points, and suppose one point divides this in ratio m:n, and wherever we have ratio, this gives a hint that we have to work or think in the direction of maybe similar triangle, right? Because there we have sides in the ratio, equal ratio. Let's draw this x and y distance in this direction. This point is x and y. As I said, whenever we see any ratio, just think of similar triangle. Do we see any similar triangle here? there are many similar triangle, right? And M is in this section and N is here, right? So if we see these two triangle, this one, and maybe I'll draw it. Oops. This triangle, I think cursor is not visible while I record this. I'll fix this. Okay, these are the two triangles, those are similar, right? And why we are doing this? Not just because the way it is defined in the book or this is explained in the book. The logic here or the direction why we are doing this, because this is dealing with the ratio and there could be multiple way to prove this. This is not the only single way. This is described in the book, so the way I am describing here. Alright, so M over N, the ratio of sides will be similar. Why these triangles are similar? That's very easy, you know, by basic mathematics. Angles are same, right? So M over N will be same as this side and this side, ratio of these two sides. What is the length of this? X minus x1, right? This is x, this is x1. X minus x1, and this is x2, right? X2 minus x, x2 minus x, and we are done. If you solve this, x, you will get mx2 plus nx1 over m plus n. And in the same way, m over n is same as the ratio of these two sides, right? So this one is y minus y1 over y2 minus y. This will also gives y is my2 plus ny1 over m plus n. Now can we try proving the external formula? The proof will be very similar. You can try on your own and then look into the solution. X1, y1, this point is x2, y2, and there is another point x and y. Again the logic is same. So what should be the logic? It will be very similar, right? So here to here and here to here, the ratio is m over n, right? So what we have to do here, we have to compare in different triangle, different similar triangle, because m is up to this point x1, y1 to xy. So this triangle, and the other things will be similar. This is n, so other triangle will be this triangle. I'm spending so much time in the proof, but this is important. If you feel this is very obvious, you can skip it and see the questions answer only. Alright, so m over n will be the bigger triangle. X will be, x is what? X minus this distance, x minus x1 over this x, the green triangle, the base of that will be x minus x2, right? This is x, this is x2 difference. And in the same way it will be y minus y1 over y minus y2, ratio of this side with respect to the green one. And if you solve, you will get x is mx2 minus nx1 over m minus n, y is my2 minus ny1 over m minus n. So this is the only concept that will be required to solve these 13 questions. There could be few more concepts like angle bisector theorem or parallelogram that we will be discussing along with the questions. Alright, so let's begin. The first question is find the coordinates of the point which divides the line segment joining the points 5, -2 and 9, 6 internally and externally in the ratio 3:1. So 2 points are given and the ratio is also given, m and n. So this question directly deals with the formula. Directly you can apply the section formula. Let's do it quickly. Then we will move into some of the advanced questions. 2 points are given, A, B. Points are 5, -2, -2, 9, 6. And we need to find a point that will divide this internally into 3:1. So this point x will be simply mx2 plus nx1 over m plus n, and y will be my2 plus ny1 over m plus n. Directly substitute 3 and cross 3 into 9 plus 1 times 5 and 3 plus 1. So this becomes 27 plus 5 over 4, that is 32 over 4, that is 8. And this will be 3 into 6 plus 1 is -2 by over 3 plus 1. So 18 minus 2 is 16 over 4, that is 4. So this point is, the answer is 8 and 4. Similarly for the external point, which will divide this in 3:1, that point will be maybe here somewhere, the here to here, here to here, and here to here. The ratio is 3:1. The similar method, this will be just negative here. So 27 minus 5 will be 22, and this will be 3 minus 1, so 2, 11. And here 18 minus plus, so 20 by 2 is 10. So the answer will be 11 and 10, and we are done. So what was the logic here? Just application of formula. We will always discuss how we came up with this solution by not looking into the book or the way it is solved described in the book. The coordinate of one end of diameter of a circle are 5, -7. If the coordinate of the center is 7, 3, find the coordinate of other end of the diameter. Circle is given. One end is 5, -7, 7, 3. We need to find this point, x and y. So how can we solve this? This is again the section thing, right? Section on middle. If we have to find a point which divides equally in between, that will be x1 plus x2 over 2, right? Because this is 1 and 1, the ratio. So let's apply that. X plus 5 over 2 is what? 7. Alright, so x will be 14 minus 5, that will be 9, and y minus 7 over 2 is 3. So y will be 6 plus 7, 13, 9 and 13. Very easy question. There is another way to also solve. Can you think of that? How can we solve this question using external division? That is lengthy way. I won't recommend to do by that way, but can we try solving that? Pause this video and try to solve. Alright, so xy, this point, what is the ratio on which this is dividing this line segment joining these 2 points? What is the length ratio of this length over this length? This is obviously 2 times of this, right? So this is dividing into 2:1 externally, right? So 2:1 externally. So xy directly you can get using that formula. So 2 into 7 minus 1 into 7, so this will be plus over 2 minus 1 is 1, so 14 plus, oops, so this will be minus 1 into 5, right? So 5 over 1, 2 minus 1 is 1, so 14 minus 5 is 9, and other coordinate will be 2 times 3 minus 1 times 7, so that will be 7, divide by 1, 6 plus 7 is 13. So this way also we are getting the same solution. So how did we solve? Using midpoint method and external division method, two ways. Moving to next question. Find the coordinate of the point which trisect the line segment joining the point 1, 2, 3, 4. Question 3. 2 points are given. 1, -2, -3 and 4. We need to find 2 points which will trisect this line, right? Let's say point A and this is point B, and obviously this is the case of internal division. So ratio of this over this is 1:1:1. But if you see the ratio of this over this is how much? 1:2. So this turned out to be problem of this point A is dividing into internally in 1:2, right? 1:2 ratio. This is not actual number. This is m, this is n, and simply use mx2 plus nx1 over m plus n. That will be 1 times 3 plus 2 times 1 over 1 plus 2, 3. So this will be -1 over 3. Similarly for y it will be 1 times 4 plus 2 times -2 over 3. 2 times -2 is 4, that is 0. So this point is -1 over 3 and 0. How to find the coordinate of point B? I will not be solving. I'll just give the ratio. This will divide this line segment into 2:1, and you can just use m is 2 and n is 1 and apply this one and my2 plus ny1 over m plus 1. You will get the coordinate. This coordinate will be -5 over, I'm just writing the answer, you can try solving. -5 over 3 and 2. Moving to next question. Find the harmonic conjugate of 4, -2 with respect to line segment joining 2, -4 and 7, -1. So this is a new term, right? We have not discussed so far what is harmonic conjugate. So if you have studied harmonic progression, this maybe you might be knowing this, but if you don't know, let me just recap what is the meaning of harmonic conjugate. So point A, B. Suppose one point P divides this segment, line segment in ratio m:n, and you find another point Q that also divides in this line segment in m:n, m over n ratio, but in it divides externally, right? This is internally and this is externally. So point P and Q are said to be harmonic conjugate of each other. Why harmonic? If you study harmonic progression, it will be more clear. Why do we call it harmonic progression? Where AP, AB and AQ will be in HP, harmonic progression. So let's look into the question. Find the harmonic conjugate of 4, -2 with respect to line segment this. There is one more important trick before solving this. Let's say you have to find the ratio on which any point divides a line segment m over n. There is a shortcut. You can use lambda is to 1 ratio also, because to deal with one variable is easy compared to two variable. Ultimately lambda will come in fraction like 5 over 2. If the value is 5 over 2, that means this is m and n, right? If this comes -5 over 2, that means this is m over n and this is external division. So you can use this shortcut. Instead of m is to n using two variable, directly you can use lambda and 1 and finally get the fraction lambda. Let's solve this question. Find the harmonic conjugate of 4 minus 2, 4 negative 2. So what is the line segment here? 2 negative 4, 7 and 1. To find the harmonic conjugate, first we need to find what is the ratio that this point is dividing this line segment. 4 minus 2. So as I said, you can consider this as lambda is to 1 ratio, right? If lambda is m over n, then lambda is to 1 is equivalent of m is to n. Alright, you can try solving using m and n. Ultimately the calculation will be little bit lengthy. When this is lambda is to 1, just apply the section formula, this into this and 1 into this x and y coordinate. So 7 lambda plus 1 into 2, 2 over lambda plus 1 is what? This point, x coordinate 4. So 7 lambda plus 2 is 4 lambda plus 4. This side 3 lambda is 2. So lambda is what? 2 over 3. M is to n. When this is positive, that means internal division. When this is negative, that will be external. So this is the case of internal division. So when this is internal division, and the harmonic conjugate will be what? The point which is dividing externally. So we have to find a point which divide this line segment in ratio 2:3 externally. M is 2, n is 3, and we need to find a point which divides it externally in 2:3 ratio. How to find that point? Use the formula of external division. So 2 into 7 minus 3 into 2 over 2 minus 3 is negative 1. So 14 minus 6 minus 1. So that will be negative 8. This is negative 8, and the other y coordinate will be 2 times 1 minus 3 times negative 4. So that will be positive 12 over 2 minus 3 is negative 1. So 14 minus 14. So answer is negative 8 and negative 14. The question says x coordinate of 2 points B and C are the roots of equation this one, and y coordinate are roots of an equation this. So quadratic equations are given, and we will get to know x and y coordinate of B and C. Also it says x coordinate of B is less than x coordinate of C, and y coordinate of B is greater than y coordinate of C. So what is the purpose of these things? Let's write down. So first equation is x square plus 4x plus 3, and second equation is x square minus x minus 6 equal 0. Alright, two equations are given, and x coordinate of 2 points, it says 2 points B and C. So the x coordinates are the roots of first equation. Find the root of equation. The first one, the sum should be 4 and product should be 3, so factorize it. Plus 3x plus x plus 3 equals 0. So x plus 3 plus x plus 3 equals 0. X plus 1 and x plus 3. So the roots are negative 1 and negative 3. Alright, negative 1 and negative 3. These are x coordinate of B and C, and we don't know negative 1 belongs to B or negative 3 belongs to B. Okay, that's why there is one more relation is given, x square minus x minus 6. So by just factorizing 3x, so the roots are negative 2 and 3 and 3, and it says x coordinate of B is less than x coordinate of C. X coordinate of B, this is x, right, x coordinate of B is less than x coordinate of C. This is B, this is C. Second is y coordinate of B is greater than C. So this is greater. Again, this is B, this is C. So the points are -3 and 3. This is -1, -2. So all these things, the purpose of these equations and relation was to find the coordinate of two points B and C. Now we know what is B and C. It says something else. Alright, the coordinate of a third point A is 3 and -5. Another point A is -3 and -5. So this will form a triangle, right? So far good. We have just used the equation and found the coordinate. One coordinate was given, other coordinate we had to find using quadratic equation. Now it says find the length of bisector of the interior angle at A. So it is asking to get the value of A and T. These are equal. If you remember from basic geometry, so these are same. We have to find the value of AD. So how to approach this problem? The length of AD we have to find, and given that this is angle bisector, and if you remember the angle bisector theorem, if this portion BD is X, DC is Y, AB and AC is given, you can easily find the ratio in which this point is dividing line segment B and C, and once we know the ratio we can easily figure out the coordinate, right? So we are using angle bisector theorem to get what? To get ratio of the portion of line segment, and using that we can find the coordinate of the point that is dividing, right? So what's the distance? 3 plus 3 is 6, 36, and 8, 64, 36 plus 64, 100. So this is 10, and 3 plus 4, 16, and 9, 25. So this is 5. X over Y, let's write it M is to N. That will be more intuitive, right? M over N is 10 over 5. 2 over N, and this problem is now very simple. You have to find the coordinate of D which divides this line segment in the ratio of 2 over 1 internally. So 2 into -1 plus 1 in -3 over 3. So -2, -3, -5 over 3. That's the X coordinate, and Y coordinate will be 2 into -2, so -4, and 3 over 3, that's -1 over 3. Now we know the coordinate of A and D. We can easily figure out the distance between these 2 points, and giving the final answer, the distance will be 3 plus negative will become positive, 3 plus 5 over 3 square. I'm just applying the distance formula, and -5, negative, positive, 1 over 3 square under root. The answer will be 14 over 3 square root of 2. You can validate this. So what is the takeaway from this problem? Two things. One is the applying angle bisector theorem, and why this is relevant, because it deals with the ratio, right? It deals with the ratio of line segments and the length of sides. Alright, moving to the next question, number 6. Find the ratio in which the point 2y divides the line segment 4, 3 and 6, 3, and hence find the value of y. This is very easy question. Question 6. 2 points are given. 4, 3, 6, 3. 2y point is given, and we have to find the ratio in which this point is dividing. So simplest way to use lambda is to 1 instead of m is to n. So this will become 6 lambda cross multiplication plus 4 over lambda plus 1 equals 2, right? Why we are doing x not y? Because y is not known. This was, did I say 2 4? No, this is 2 and y, this is unknown. This is known, so whatever is known we will calculate based on that one, right? So 6 lambda plus 4 over lambda plus 1 is 2, and if we solve this, 2 lambda plus 2, 4 lambda is negative 2, so lambda is negative 1 over 2, that is m over n. And when the sign is negative, this is external division. Although we are using the formula of internal division, lambda is to 1, but whenever this sign comes negative, that means this is external division. Alright, so this will not lie here, it will lie somewhere else outside this segment. Why are we saying when this is negative, this is external division? Because if we see the formula, right, this will become kind of this, right, instead of plus to minus. That's why this is external division. Now the problem is simplified to find the y coordinate of the segment of the point, which will divide this into 1 is to 2 externally, right? 1 is to 2 externally. So let's apply that. 1 into 6 minus 2 in, sorry, not y coordinate we are dealing, right? It's 3 and 3. So 1 into 3 is 3 minus 2 into 3 is 6 over 1 minus 2, negative 1. So that will be negative 3 over negative 1, that is 3. So the answer is 3. This coordinate will be 2 and 3. What are the takeaway? Use lambda is to 1. Whenever this is negative, this is external division. Question 7. Let's read the question. If A, B, C and D are points whose coordinates are, the coordinates are given, 4 points A, B, C, D. Respectively find the ratio in which AB is divided by CD. So 4 points, 2 points will make one line, another 2 points will make another line, AB and CD, and we have to find the ratio in which one of the line is dividing another. AB is given, so A, B, negative 2, 3, this point is 8, 9, let's cross checking, 0, 4 and 3, 0, CD, C, D, this is 0, 4 and 3, 0. So how to solve this problem, right? Finally, we will see the takeaway also. What are the key learning from this problem? To solve this problem, we have to use two concepts. Let's assume this point is x and y, and once the point is given, to find the ratio in which this point is dividing, we use lambda and 1. That's a shortcut. Suppose this point divides in lambda is to 1, we will get to know this point, right? Lambda in this term, this in form of one variable. And once we get to know that point, we have something else. This point should lie on this line as well. That's why this is intersecting, right? So what is the constraint there? There are multiple ways to prove that the point, 3 points are collinear. You can use distance formula to get the distance. The sum of two distances same as third distance, or else you can prove the area of triangle is 0. You can use any of the method, but I am going to use area of triangle method. Area of triangle is something I have not covered, but for now you can just, I'll give the way how it is calculated using determinant. You can use that, and I'll be covering the proof in another video. Alright, that's the way we'll be solving. So what will be the point here? If the ratio is lambda and 1, this point will be cross multiplication 8 lambda, this is 2 lambda plus 1, and y will be 9 lambda. This side will be 3 over lambda plus 1. We now know this point, and this has to lie on this line segment. Ultimately what we have to find lambda, right? And at what ratio this line is dividing AB. The question could have been in reverse way also. At what ratio AB is dividing this segment? So we have to you have to think lambda and 1 in this direction and doing the collinear method in different way. So 3 points are given. 0, 4, middle point, 8 lambda minus 2 over lambda plus 1, 9 lambda plus 3 over lambda plus 1, and this point is 3, 0. So there are two ways to solve, but the easiest one is to use the area method, where x1, y1, x2, y2, x3, y3. The area of triangle is 1/2 x1, x2, x3, y1, y2, y3, 1, 1, 1. If we prove this as 0, that means these points are collinear, right? So let's do that. This is x1, y1, x2, y2, x3, y3. We will get to know lambda. 0, 8 lambda minus 2 over lambda plus 1, and 3, 4, 9 lambda plus 3, lambda plus 1, and 0. This will be 1, 1, 1 equals 0, and find the value of lambda. You can multiply lambda to here, lambda plus 1, this will become lambda plus 1. Let's try to solve this. I hope you know how to calculate the determinant. You can alternate plus, minus, plus, like way. 0 times this minus this, but this will be anyway 0. So 4 times, negative 4 times, you just exclude these two things. This will become 8 lambda minus 2 into 1 minus 3. 3 times this. So 3 lambda minus 3 plus 1, and exclude these. So this will be 0 and minus. So minus 27 lambda minus 9 equals 0. And if you solve this, you will get value of lambda as 11 over 47. That is m is to n. What is the answer? So what is the meaning of this? This one is dividing. Which one is dividing which? A, B, C, D. AB is, sorry, CD is dividing line segment AB. That's what it was asked, right? Find the ratio in which AB is divided by CD. So AB is dividing CD in the, find the ratio in which AB is divided by CD. So divided by CD, this will be lambda is to 1, and lambda was 11 is to 47. So that's the ratio. Moving to question 8. It says A1, A2, A3, A4, AN are n points in a plane whose coordinates are x1, y1, x2, y2, and so on, x and yn respectively. Alright, A1, A2 is bisected in the point G1. So let's keep drawing it, then it will be clear. Question 8. Oh, we are almost halfway. Total 13 questions are there. So it says A1, A2, 2 points are bisected in the point G1. So A1 is what? X1, Y1. A2 is X2, Y2. G1 bisect it. ratio 1:1. So G1 will be x1 plus x2 over 2, y1 plus y2 over 2. Now we know what is G1. Then it says A3, the point A1, A2 is done. G1, A3, what is G1, A3? G1, A3, let's say somewhere it is here, A3. We don't know. The length could be anything. G1, A3 is divided at G2 in the ratio 1:2. 1:2. So it will be somewhere here, right? This will be 1 and this will be double of that at point G2, I believe. G2. Okay, when this ratio is 1:2, the point this will become this is what, x3 y3. So x3 plus 2 times of this, right? X3 plus 2 times of this will be what? X3 plus x1 plus x2, right? 2 into 2 cancel by over 3, and similarly y1 plus y2 plus y3 over 3, right? 2 plus 1, 3. Next it says G2 A4. A4 is, let's say, somewhere here. A4 is x4 y4. G2 A4 is divided at G3 in the ratio 1:3. So this is 1. This is closing out, right? G3 is 1:4, and by internal division to get the coordinate of G3, why we are getting the coordinate? Because we have to ultimately prove at the end. If you see at the end, it says G1, G2, G3, G4, G6, so on until all points are exhausted, so that the coordinate of final points so obtained are this point. So we have to keep calculating so that we reach at the end G1, G2, G3 like this till we exhaust all the points, nth point. So the coordinate of this will be 1 times x4 plus 4 times, sorry, this is 1:3, right? This is 1:3. G3 is G2 A4 is divided at G3 in 1:3. 1:3. So that this will become x4, right? Cross multiplication, x4 plus 3 times of this. So 3 is cancelled out. Everywhere you see it's cancelling out. 2 is cancelled with this, 3 is cancelled. So we are getting one pattern, right? So this will be x1 plus x2 plus x3 plus x4 over 4, and similarly so on. And if we keep doing this, at the end you will get final point will be what? x1 plus x2 plus xn over n. That's what we had to prove. Okay, so final point will be x1 plus x2 plus so on, xn over n, this. That was very easy question. The only thing we had to use to apply the formula in a recursive way. Let's move to next question, question 9. So that the straight line ax plus by plus c, I'll come to this, the equation, how does any equation represent line? Divide the join of point x1, y1 in the ratio of this. Basically what it says, when 2 points are given, x1 and y1 and x2, y2, this is given, right? x1, y1 and x2, y2, and we have to find the ratio in which any of the line divides this point, right? The equation is ax plus by plus c equals 0. Although we will be discussing more detail on this equation of line and so on. Let's assume this is lambda is to 1. Always when the ratio is not known, we will be using one variable, introducing one variable instead of 2, lambda is to 1. So this point will become lambda x2 plus x1 over lambda plus 1. And similarly for y, lambda y2 plus y1 over lambda plus 1. And once we know the point and the equation of line is given, that means each of the point will satisfy this equation, right? This is equation that is universally true for each of the point on this line. Just put it here and you will get the ratio in which this will divide. So when this will become 0, so just put it here a times lambda x2 plus x1, lambda plus 1 we will keep this side, so this will become 0, so plus b lambda y2 plus y1 plus c lambda plus 1 equals 0. And if we simplify this, or let's simplify this, right? There is a pattern here. Ax2 plus by2 plus c, right? Plus, without lambda term, ax1 plus by1 plus c equals 0. So lambda is what? Negative of ax1 plus by1 plus c over ax2 plus by2 plus c. We'll be solving this question, but in fact the application of number 9, right? These are the variables, but this is the one specific example in which 2 points are given and we have to find the ratio. Alright, so let's do number 10 quickly and then we can move to 11. What it says, a line L intersect three sides BC, CA and AB of triangle ABC. So let's create one triangle. A, B, C, any line, let's take any line. So it says BC, it divides at P. BC, it divides at P. Back to black color, P. And CA, it divides at Q. CA, let's extend this. It divides at Q. And AB, it divides at R. Okay, and we have to prove BP over PC, BP over PC, this ratio of this one. And we already proved here, right? We have one result here. Any line divides in a line segment in a specific ratio, and that is, let's assume the equation of this line is ax plus by plus c. So what is the result here? This will be divided into BP over PC will be what? Let's say this is x1, y1, x2, y2, x3, y3. Alright, so these are the 2 points, and this will divide into ax2 plus b y2 plus c over negative of ax3 plus by3 plus c. This is one result we can use for this ratio. What are the other ratios? CQ over CA. CQ, okay, I'll come to this at the end. Other is AR over RB. AR over RB. What will be the ratio of that? AR over RB will be x1, x2. So this will be ax1 plus by1 plus c over ax2 plus by2 over c. And this is dividing, this is going outside, but that doesn't matter. That's a generic result. So that is CQ over CA. CQ over CA will be, this will be ax3 plus by3 plus c over ax1 plus bx2 plus c. And if you multiply all these are all negative. So that's what we have to prove, right? Multiplication of all these ratio in which the line is dividing all three line segment is -1. Can we multiply this? Do we see any pattern? ax2 plus by2 plus c, ax2, this cancelled out, ax3 plus by, this cancelled out, ax1 and this cancelled out, and -1, -1, -1, you will get -1. All right. So we are done with question number 10. Let's move to 11. Question number 11, this is a specific case of number 9. What it says, find the ratio in which the join of point 1, 2 and -2, 3 is divided by the line 3x plus 4y equals 7. So question number 11, it says 2 points are given. What are those 2 points? 1, 2, negative 2, 3, and one equation of line. Equation of line is this line could be anywhere. This could be like this could be this, we don't know, right? So let's just put one line. This one is 3x plus 4y, but slowly you will get to know what is the meaning of this equation and how to plot the slope and those things. All right, we have to find the ratio in which this line is dividing. Let's assume this is lambda is to 1, cross multiplication, negative 2 lambda plus 1 over lambda plus 1, and this point will be 3 lambda plus 2 over lambda plus 1. These are the 2 points, and since this is on this line, this will satisfy, right? So 3 times of x, that will be negative 6 lambda 3, so this is 3 lambda plus 1, we will get this side 7 lambda plus 1, and 4, so this is 12 lambda plus 4 into 2 is 8 equals 7 lambda plus 7, 7 lambda plus 7. Alright, so 12 minus 6 is 6, 7 minus 6 is lambda, lambda equals what? 3 plus 8 is 11 minus, sorry, this is 7, 7 lambda plus 7. So 11 minus 7 is 4. So lambda is 4 or 4 is to 1. So this is dividing into 4 is to n. Let's move to next question. Question 12. Question number 12 is related to parallelogram. I've just added because there is some midpoint concept we can use here, but I'm planning to create another video on geometrical results on parallelogram, rectangle, square, rhombus, those things. Alright, so let's see this. Prove that the point, these 4 points are vertices of a parallelogram. And if you remember from your basic geometry, in any parallelogram, diagonals bisect each other. Alright, so if we prove that these points, these are in cyclic order, right? A, B, C, D, negative 2, negative 1, this is 1, 0, 4, 3, D is 1, 2. If you prove that midpoint of this segment BD and AC is same point, that means that is parallelogram, right? So what is the midpoint of this? 4 minus 2 is 2. 2 over 2 is, using this segment, right? AC, midpoint of AC is what? 4 minus 2 over 2, that is 1, and 3 minus 1 is 2. 2 over 2 is 1, 1, 1. Alright, and midpoint of BD is 1 plus 1, 2. 2 by 2 is 1, and 2 plus 0 by 2 is 1. The midpoint is same for the diagonals. That's why this is parallelogram. Moving to the last question. Question number 13. The vertices of a triangle are given ABC. If the internal bisector of B meets the side, that is opposite side, right? In D, find the length of AD. And if you recall, one of the question we already did, where that was question number 5, and it had involved another one more step to find the coordinate of B and C also. In this question, all the vertices, the coordinate of vertices are already given. So let's try to solve this. This will also be quick. So let's, what are the coordinates? A, B, C, the coordinate points are given, negative 1, negative 7, B is 5, 1, C is 1, 4, angle bisector of B, it meets at point D, and we have to find the length of what? AD, okay. Actually, we can find any of the length AD, CD, BD once we get to know the point D. Okay, how to know this point? You just recall the question number 5 that we solved using angle bisector theorem. Alright, if this is X, this is Y, So x over y will be the length of the ratio of length of BC over AB. So what is BC here? 5 minus 1 is 4, so 16 plus 9, that is 5, and this is 5 plus E, 36 plus 64, 10, so this is 5 over 10, that is 1 over 2. So we know this is 1, this is 2, right? That is the ratio it is dividing. So use the section formula to get the point. And I think I can leave it for you, because the ratio is given and the points are given. You can easily find the coordinate of D. Once we know the point, you can calculate BD, AD, CD, or any of the point. Because the coordinates are given, then you can use distance formula. So this is all about basics of section formula. And in the next video, I'll try to cover in-center, orthocenter, centroid, and those kind of concepts. See you then. Bye.